All right, here is a moments of inertia problem for a composite cross section. We see this green cross section here. We're asked to find the centroid, and then after that, with or based on that, the moments of inertia and the product of inertia of the about the x prime and y prime axis, and then the radii of gyration for those as well. So, first thing we need to do is we need to figure out how we are gonna divide up our composite area here. Maybe take a different color. All right, so we could think about doing. Oh, where's my pen? There we go. Well, we could think about something like triangle there, maybe rectangle there, triangle there, rectangle there, right? So we'd have 1, 2, 3, 4, 5 cross sections or shapes that we have to deal with. However, I think we have one that's a little easier. And let me erase these real quick. I think we'll be better off if we use a hole or multiple holes. So we'll say basically our overall shape is a rectangle like this. If I could draw straight, right, that's our overall rectangle. And we'll say that basically we have our triangle hole right here, rectangle hole right there, and another triangle hole right in there. Right, so I think that's what we're going to do. So we are going to break this apart. We're going to say the overall rectangle is 1. This little one is 2, I'm sorry. This one is 3, and that one is 4. So maybe just to get ourselves going here, we'll do it in blue. We can have our 3 shapes. Right? We have our shape, our rectangle, our main rectangle, and that is 30 by 26, right? Look up here. From here to here is 26 plus 4. In this direction we have 8 plus 8 is 16 plus 10 is 26. That's that one. Then we have a triangle like that. All right, so this was 1. This is 2. This is negative because it's a hole. We have to put a minus sign in there. Now these are also 30 in length. And the height of that one is 5 centimeters, 8 centimeters minus 5 centimeters. So 3 centimeters. Then we have the one down there. Another triangle, so that would be number 3. Also negative. No, let's put the 3 somewhere else because would be a better spot for the width. So the width, of course, also is 30. The height is the same as 3, and then we're left with the third hole, which is a rectangle. Negative. It's 4, and it is, let's see, it should be 26, right? It says from there's 26 by 10. It says everything exactly there. 26 and 10. Excellent. And now we can start finding where our centroid is. Now it's asking for the centroid from point A, but based on our overall setup, I think we'll do it from this corner down here. So we'll start counting everything from the corner down there, and then we can convert it after all. I'll just translate it to be there. All right, so that means we need to have a table with 4 entries, 4 lines, 4 rows. We need I, we need AI. Nope, that is in centimeters squared. Sneak that in there. X bar I will be in centimeters. Y I bar in centimeters, and then xi bar times AI centimeter cubed, and that should be y, not another x. yi bar times AI in centimeters cubed. And we have 1, 2, 3, 4, and the sum. All right, so all we need to do is fill out that table. Now, one thing that we can see from our shape right away is that it is symmetrical. So we know that we're gonna kind of know where our y bar is gonna be, but we're gonna need all the yi bars later on anyway, so we'll fill them out in this table, right? So this is symmetrical about this line, so we know that the y would be, if I count from here, 8 centimeters, 13 centimeters. Right? But again, later on we'll need all these extra pieces. All right, so the areas would be, if we start with 1, that would be 26 times 30, and that is 780. All the other ones are negative, right, because they're wholes, so this would be 1/2 times 3 times 30, so minus 45. Same one for the third one, minus 1/2, 3 times, I don't like to draw all that small, does it? 3 times 30 minus, now both of them look bad. I hope that one would fit. Let's clean that other one up too. So this was supposed to be a 3, and this was supposed to be a 4. There we go. And then the last one is this one. That would be minus 26 times 10 minus 260. Now, if I add those all together, I get 430. No adding here. Then xi. Again, we're going to be starting from blue here. This is our starting point. All right, so if I want to do for my overall one, it's just going to be half in x and half in y. So I can say it'd be 1/2 times 30 is 15. 1/2 in of 26 is 13. Now let's see. 2 in the x direction is just going to be 1/3 times 30, right? My length here. I'm starting at that, so we're good. So it'll be 1/3 times 30 is 10. In the y direction, I'm going up. How far? This would be 8, 18. Or maybe go the other way around. 18. 18 plus 5 is 23. So 23 plus 2/3 of 3. Guess. 23 plus 2/3 times 3 would be 25. But the other way we could do is we could say, well, we know it's 26 all the way up and go 1/3 down. Comes out to be the same. Now 3 is the one down here. Don't have to worry about adding anything. So the x direction would be 1/3 times 30 is 10. In the y direction, 1/3. Is it 1/3 or coming from here? Yeah, 1/3 times 3 is equal to 1. And then for this one, we need to add 4 and then half of its size. So 4 plus 1/2. 4 plus 1/2 times 26. That should be 17. And then in the other direction, we're going 8 plus 1/2 in the height. So it'd be 8 plus 1/2 times 10. And that is 13. All right, so that's all good. So now we can do our xi's here. That'd be 15, 10, 10, and 17. Our yi's are 13, 25, 1, and 13. 13, 1, 25, 13, 15, 10, 10, 17. Okay, that looks good. Then the area is 780. 780 minus 45 minus 45, also minus 45, and then minus 260. All right, so that means we need to plug in these numbers. This is 11,700. This is minus 450. That one's easy. That one's also minus 450. This one is minus 4,420. Going up here, 10,140 minus 1,125 minus 45. That's again easy. And this one is minus 3,380. So we can add all this together. 6,380 here. 590 there. So I know that X bar is going to be 6,380 centimeters cubed divided by 430 centimeters squared gives me 638 over 43. These fours are getting annoying. 43 centimeters. If I calculate that out, 14.837 centimeters. That would be my centroid here. And then in the y direction, that's the one that we are confident that we already know, 5,590 over 430. That is centimeters cubed squared. That gives me exactly 13 centimeters. Now, if I wanted to get it in terms of A, right, then all we'd have to do is subtract 3 centimeters, so it'd be 10 centimeters, right? Basically, if I say distance to the centroid is 13 centimeters from this point, then the distance from that one is just 3 less, right? So there's nothing, the y one stays the same. All right, so that gives us our centroid. Now that we have our centroid, we can go ahead and find our moments of inertia. Right? For that, we'll need another table. Do multiple tables because it doesn't fit on one page. So let's see. We will have I. We will have I xi prime bar. This will be centimeter to the fourth. We will have I yi prime bar, also centimeter to the fourth. And then we have I xi prime yi prime bar, centimeter to the fourth. 1, 2, 3, 4, and the sum. Oops. Let's started a little too far over there. All right, so here is our table. Now let's think about this for 2 seconds. There are our shapes, right? So we have triangles and rectangles. We can find those pretty easily. So if we think about our rectangles, they're going to be bh cubed over 12. The other ones are going to be over 36. So you have to remember that the negative ones are negative. All right, let's start with the first one, right? Had a width of 30 and a height of 26. So 30 times 26 to the third power divided by 12 is 43,940. The next one again is negative. This is a triangle now, so we'll divide by 36. So this is 30 times 3 to the third power over 36, and that is minus 22.5. Now the next triangle is going to be exactly the same, right? For ix and iy, it doesn't matter what the triangle looks like. 30 times 3 cubed over 36 minus 22.5, and then we have a rectangle again, and this is 26 by 10. So we have minus 26 times 10 to the 3 divided by 12. Didn't get myself much space there. All right, this is one that we can't easily describe, so this is 6,500 over 3. So that means if we want to stay accurate, we'll transform all of these to thirds. So we have 125,185 thirds. That was our ix prime bar. Now for y, right, all we have to do is switch this around. So we have 30 to the third times 26 over 12 is 58,500 minus 30 to the third times 3 divided by 12. That is minus 2,250. Same again, 30 to the third times 3 divided by 12 is minus 2,250. And then this one here, of course the one that I have the least space, it's the most difficult one, 26 to the third times 10 over 12 is equal to minus 43,940 thirds. So if I add those together, 118,060 over 3. All right. Now our ix bars. Well, we can start with the two rectangles. There's 0. Always easy. Boom and boom. And then we have to look at our triangles. So this triangle has the corner up here, right? That's one of the ones that is positive, but it's still negative because it's a hole, right? So we have 30 squared times 3 squared divided by 72, and that is minus 112.5. And then the other one, the other triangle here, this shape of triangle, this orientation, is one of the negative ones. So we have double negative, minus 30 squared times 3 squared divided by 72. And that's, of course, then just 112.5. Means those two cancel out. Which makes sense because, if we think about the moment of inertia, right, overall, the two parts should cancel out. All right, so that's our IX's. Then maybe we'll just do a table with our DX's. So we have I, and we have DXI, which remember is X bar I minus X bar. That's going to be centimeters, and similar DYI is YI bar minus Y bar. 1, 2, 3, 4. No sums here. Lots of space. All right, my XI from up here, 15, 10, 10, 17. 15, 10, 10, 17. Minus, this is the X bar, is the weird looking one, 638 over 43. 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 First one, if I do that, I get 7 over 43. The second one, I get minus 208 over 43. The next one, I should get the same thing. Minus 208 over 43. And then for the last one, I get 93 over 43. All right, the dy should be a little easier because it's better, nicer numbers. So 13, 25, 1, and 13. 13, 25, 1, and 13. That's what I had, right? Let's see. 13, 25, okay. And my overall was 13. Minus 13, minus 13, minus 13, minus 13. 13 minus 13 is 0. 25 minus 13 is 12. 1 minus 13 is minus 12. And 13 minus 13 is 0. All right, so we have our dxi and dyi. So then we can get our parallel terms. So we can have I dxi squared times ai. This is now centimeter to the 4. We have dyi squared times ai, centimeter to the 4th. And then dxi times dyi times ai, centimeter to the 4th. And 1, 2, 3, 4, and the sum. All right, so do we have enough? Can we just sneak those in there? Excellent, we can. So dxi, we would have 7 over 43 squared. Let's just write the dx's and then we'll go and get the minus 208 over 43 squared minus 208 over 43 squared and 93 over 43 squared. And then where are the areas? 780 times 780 minus 45 minus 45. And then for the fourth one, where's our area? Minus 260. Minus 260. All right, so for dy, play the same game. Now this is a little simpler. So 0 squared, you can see the area right there, 780. We get 12 squared times minus 45. We get minus 12 squared times minus 45. And we get 0 squared times minus 260. All right, we want to start with these couple here. So this one gives me, I'm giving up on the on the fractions here, 20.671. This one gives me minus 1052.9. Same, of course. Oops, 1052.9. And this one is minus 1216.2. Add that all together, minus 3301.4. This one, that's 0. This one is minus 6480. Same here, of course, 6480 and 0. So basically we get 2 times 6480 is 12,960. All right. We are slowly but surely getting there. Now, dx dya would be 7 over 43 times 0 times 780. There right away, that's 0. Then minus 208 over 43 times 12 times minus 45. Let's just write those in there. Those are left for some reason. 112, 320 divided by 43. Then I get minus 208 over 43 times minus 12 times minus 45. So we should get the same with just a different sign. 112,320 divided by 43. And this one would be 93 over 43 times 0 times minus 260. And that's then, of course, equal to 0. That's easy enough. Now, if I look up here, these two cancel, the rest is 0, so I get a big 0 in there. Excellent. So now we've got everything that we need to get our moments of inertia. We get I x prime bar would be Ix, sum of Ix was this year 125, 185. 125, 185 over 3 centimeters to the fourth plus the dy, right? That would be minus 12,960. So if I add those together, I get 28,768 centimeters to the fourth. That is Ix. Iy prime bar. Let's see, where's our Iy? Was 118.60. 60 divided by 3 centimeter to the fourth, plus, now it's my dx, so this one here, minus 3,301.4, and that gives me 36,052 point, no, I didn't do anything there, centimeter to the fourth. And then the product of inertia, Ix prime y prime bar, 0 here, 0 centimeter to the fourth, plus 0 for this one. That's easy math to do. Gives me 0 centimeter to the fourth. And we kind of already knew that, right? If we think about that, where is it, right? Our centroid is going to be somewhere along here, so this is definitely an axis of symmetry, so it should be 0. All right, then the last part we have to do is kx prime and ky prime. Kx prime bar is equal to Ix prime bar over A is gonna be Ix prime bar is that big number there, so 28,768 centimeter to the fourth divided by, where did we have our A? Was it? That's the wrong one. 430. 430 centimeters squared. If I put that into my calculator, 8.1794 centimeters. Ky prime bar, Iy prime bar over A is, we can see it up there, 36,052 centimeters to the fourth divided by 430 centimeter squared gives me 9.1565 centimeters. Very good. All right, so that was a little bit of a slog, but now we've got everything that we need. We filled out all our tables in order for us to find out what the moment of inertia around the centroid is, and also what the radii of gyration are.